would you believe it? I was working with my Vibraplex, and this is my side tone, my code practice oscillator. It's an MFJ-554. I really like it. And I wanted to look at switch bounce. So I rigged up an oscilloscope across the contacts here, these two contacts here. And as soon as I put the ground probe on, I think I shorted something inside here, because now you can hear it. You're just getting this dull audio tone. It's yeah. So it's as if it's key down all the time. And so looks to be a single-sided board, lots of SMD stuff to get stuck into. I need to debug this little thing to figure out what is going on. Get it back working. Okay, so taking this thing apart, let's have a look inside it. This is the MFJ-554 Morse Code practice oscillator. It's essentially a two-sided board. There's no components on the back. Theory of operation is basically you put a straight key into the jack, so it's not a keyer. It's just a tone oscillator. You put a straight key in here, so you have one contact that you're closing when you put key down, and essentially you have a signal path which comes into this device here. This is a quad op-amp chip, and I guess this is used for the generation of the sine wave, the sine wave tone. Now I've seen circuits where they use 4 op-amps to produce a very nice high-quality sine wave, like a Bubba oscillator. They could be doing that here. I haven't really tried to re-engineer this to figure it out. But essentially, you'd have your frequency control here, your tone control, you'd have your volume control, which controls the other major chip here, which is the 1-watt audio amplifier, which then drives the speaker and off or external speaker output. Over here, you've got your 8-volt regulator, which is taking 12 volts from the DC supply and then stopping it down to 8 volts. So essentially, yeah, you have power going in, 8 volts. You then have this sine wave generator here, producing a high-quality sine wave, then pushing it to an audio amplifier and out. The only thing you need to trigger is to generate that sine wave, and that seems to come from this signal path here. You close the key, and this single line goes right through to this FET, this Q1, which is a 2N 7002 N-channel enhancement FET. And I'm not exactly sure how that's controlling it right now, but essentially when you put key down, you would expect to ground this this input line. So this is the gate, this is the source is connected to ground, the gate is held high from the supply voltage through these pull-up resistors, and when you put key down, you then drag the gate down, and I think that, well, yeah, it then allows the thing to make a tone. Not exactly sure how it's working, but this FET seems to be, it doesn't really have a high impedance across it. Something like about the gate to source is about 150 ohms. So it's kind of partially on, which makes sense because the output of this sine wave is it's on, but it's kind of on a low volume. It's not really full on as far as I can tell. So the high culprit right now, the primary suspect, is this FET, and yeah, we're going to have to do a bit more debugging, but I think if this FET is dead, we'll swap it out and see if we can get the keying action to work again. So key down, this pulls the gate to ground, and this allows the chip to produce output and amplified and speaker. Anyway, That's a rough and ready estimate right now. The other thing, the standout thing over here, I think this is part of the key shaping control. I think that's something in the manual I'll double check that. So when you put key down, you get some bounce control, debouncing through this part of the circuit. I don't know. I'm making this up as I go. But I think that FET is dead. Okay, so this is the FET. I think it's dead or partially damaged. It controls the power voltage to the other components, the oscillator and the power amplifier. So and basically you activate the tone control when you ground this, so to ground the gate by closing the Morse code key. So I'm going to pull this off, and we're going to have a look to see if that chip is actually damaged. So let's go 390 degrees, 10% air volume with an 8 mil nozzle. And we'll just kind of warm it up. All right, I don't know if that's still on camera. Took a little while, quite a lot of copper lying around. Hope I haven't totally messed up that solder pad. Looks like it's a bit loose, but we have the component off, and we'll try to test it. There it is there. So having pulled it off the board, this FET, it is very, very small. So I've just wired in a few spare leads off some old resistors and stuff just to kind of connect it up. So let's see what this FET is doing. Two diodes back to back. Okay, that's interesting. Two diodes. Zener diode 1. I think it's two Zeners. Interesting. With okay. Diode 2, Zener diode 2. Okay, that is, clearly something's wrong with this part. This FET this device certainly can detect a FET, N-channel FET. So it thinks it's basically two diodes basically going this way and this way, and that's kind of wrong, right? For a start, I've measured also the impedance between the gate and the source, and something like 200 ohms. So I think that's obviously a flag, an issue. Just to show, if I unclip this and kind of show you, I have here a FET, traditional shape. This is an N27, 2N7000 FET. And if we just, bear with me 1 second, plug this in with one hand. And the other one, ooh, right. So if we switch it on, see, it knows what an NFET is and gives you all the details. So yeah, this is should be an N-channel MOSFET, a 2N7002, but clearly something has gone awry. So I have some replacements right in here, tiny little things. These are, what is it? What size are these things? Like 2 mil by 1.5 mil or something. They're absolutely tiny. So we're going to pop one in and hopefully get the code oscillator working. So having removed this FET, which I suspect is broken, the question occurred to me, what is the circuit doing now without this FET in place? In fact, it's working perfectly, assuming that the key that you insert is down. We're getting a nice sinusoidal wave. You can change the frequency, and it's loud, which is much louder than it was in the original fault state. And so we can say that with the key down, it behaves just like no FET at all. Now, in that circumstance, for a start, there's no current flowing through the gate because, well, basically there's certainly nothing to leave the gate for. There's no path. We can also say that the gate to source impedance is infinitely high, which is true because there's nothing there. And that would be probably true of a well-behaved FET anyway, because they are electrically isolated. But importantly, we can see that there's an infinite impedance between the drain and the source in this example. So this thing works beautifully when the drain source impedance is very, very high. And that tells us that the FET, a good, well-behaved FET, should be off. And so with key down, this turns the FET off and the tone is produced. So does that mean if I artificially pretend that my magic FET here, there isn't one, but if I turn the FET on, then it should stop the tone? So to replicate this, I'm simply going to produce a small conductive path between the drain and the source. So when a FET is working correctly and you switch it on, the drain source path is conducting through the drain source path. And I'm going to do that with a 10 ohm resistor. So let's see what that does. All right, 10 ohms across the drain source. There you go, switches off. So when the key is up, this FET should conduct, as I'm showing it now. Oops. And you have no tone. Key down, you turn the FET off, and you get the tone. So I think if we have, so I think that's explaining the logic of it. Okay, great. In the fault condition, which I observed earlier, this FET was sort of kind of on. And we saw that difference when it was making the tone. There was a high-ish, well, not really a high-ish, it was about 150 or 170 ohms impedance, I think, across the drain and source. And that let it turn on a little bit. And so the volume, the tone was there, but the volume was low. It wasn't very loud. And this thing is a classroom code oscillator, and it can fill a room, so it should be very loud. So I've ordered some new parts, put on a new transistor in there, and I think if that's working properly, then we should have it fixed. Okay, we have installed a new FET, just the one. Where's the mouse here? Replace that FET into the circuit, and I think that's cured it. Maybe switch it on. The light is on, but there's no tone. So that is good. And if we plug in the Vibraplex here, doing this on camera, I should look where I'm doing it. There we go. All right, it's working. Woo! Problem solved. 73.